Think about how many times a day you do this. Tapping, swiping, pinching the screen on your phone. It feels so natural, right? Almost like an extension of your own mind. But have you ever actually stopped to wonder what is happening underneath that glass? Well, let's pull back the curtain and find out. So, what we're going to do is trace the journey of a single touch. We're going to follow it from the moment your finger makes contact all the way to the digital command that launches your favorite app. It's this incredible high-speed story that happens right under the surface. And yeah, that's the real mystery here, isn't it? Because at the end of the day, that screen is just glass. And your phone's processor, it only speaks the language of ones and zeros. So how on earth do you bridge that gap? How does the physical world talk to the digital one? Honestly, the best way to think about it is as a conversation, a very, very fast and incredibly precise one between the screen itself and the chip that acts as your phone's brain. And it all happens invisibly, in just microseconds. Okay, so if it's a conversation, we need to know who's talking to who. In the world of electronics, they have a map for that. It's not paper, of course. It's a web of circuits and pathways, and it's called a schematic. Okay, whoa, I know what you're thinking. This looks incredibly complex, right? Like the wiring diagram for space station. But don't worry, we're going to break it down together. This schematic, this is the actual blueprint for how a touchscreen connects to the rest of the phone. So a schematic is basically our guide. You can think of it like sheet music for an orchestra. It tells every single component what its job is, when to do it, and how to stay in perfect harmony with everything else. Every single line on that diagram has a purpose. All right, so if the schematic is our map, then all those lines connecting everything, those are the roads. And zipping along those roads are messages, which we call signals. So to understand the conversation, we've got to learn the language. And look, the good news is we do not need to understand every single one of those lines. To really get the whole picture, we just need to focus on a few key signals. So let's put on our translator hats and decode the most important messages. First things first, you need power. It's the most basic thing, right? This line here, VDD1V8, it's not carrying some secret message. It's the lifeblood. It's just delivering the raw 1.8 volts of energy that allows any messages to be sent at all. Without this, the screen is just a dead piece of glass. Next up is a signal that, let's be honest, we can all relate to. The reset line, or CTP_RST. This is literally the hardware version of have you tried turning it off and on again? If the touchscreen controller ever gets confused or freezes up, the phone's main processor can send a quick pulse down this line to force a reboot and give it a fresh start. Okay, now this one is a huge deal. It's called the interrupt line, or ENT_CTP on our map. See, your phone's processor is always juggling a million things. It can't waste energy constantly asking the screen, hey, you been touched yet? How about now? So instead, the screen has this dedicated line to send an urgent message, an interruption, that basically yells, hey, stop what you're doing, I have information for you. This is the signal that kicks the whole thing off. So, the wake-up call has been sent. The processor drops what it's doing and is now listening. But you can't just have the two components shouting data at each other randomly. You need rules, a grammar for the conversation, to make sure nothing gets lost in translation. And that's called a communication protocol. In this case, they use a super common protocol called SPI. Let's just break down the key parts. You've got SPI_CS. That's chip select. It's the processor saying, okay, I'm talking specifically to you now, touchscreen. Then there's SPI_CLK, the clock. Think of it like a steady metronome beat that keeps both sides perfectly in sync. And then you have the actual data lines. SPI_D0 is data out, which is how the screen sends the touch coordinates, and SPI_D1 is data in for receiving commands back from the processor. It's a really disciplined four-part conversation. Okay, we have our map, we know the key vocabulary, and we have the rules of grammar for the conversation. So now, let's put it all together. Let's follow the complete journey of a single, simple tap. So check it out. It's this precise 5-step dance. Step 1, your finger makes contact. Easy enough. Step 2, boom, the screen sends that wake-up call, that interrupt signal. Step 3, the processor hears it and uses the chip select signal to say, okay, you have my full attention. Step 4, guided by that steady clock beat, the screen sends the coordinates, the where of your touch, down the data outline. And finally, step 5, the processor gets those coordinates and turns it into an action, like opening an app. The whole thing happens in a fraction of a second. It's unbelievably efficient. When you really stop and think about that process happening over and over, thousands of times a day, for every single scroll, every tap, and every swipe, you start to appreciate the absolutely insane level of engineering we just carry around in our pockets every day. Let's just look at our map one last time. That entire five-step journey we just traced, from the wake-up call to the final data transfer, it all happens right there, across those tiny connections in a sliver of a second. It's a true masterpiece of miniaturization and speed. So what you're really holding isn't just a phone. It's an invisible, bustling metropolis of information. A city of signals racing down microscopic highways, all following strict traffic laws, working in perfect concert just to make your digital life feel seamless, intuitive, and, well, like magic. And that's really the big takeaway here. All of this incredible complexity is hidden right behind a simple piece of glass. It really makes you wonder, doesn't it? What other invisible worlds are humming away inside the technology we take for granted every single day?